We're given a vector equation describing line L, and then P has this position vector. And then we're told that P dash is a reflection of P in L. So I'm just going to get a diagram down for what is going on here. Okay, so here's my line L, and I'll say that the origin is here, and then some vector gets us onto the line. In fact, that is this vector here, the position vector 13, minus 3, minus 8. Okay, meanwhile, up here, we have P, and then a reflection in the line takes us to this point, P dash. So I'm going to label this point X, and because it's a reflection, then this is going to be at a right angle. So to start with, I've got OX. Actually, OX is simply going to be essentially my R, but for some specific value of t. And then what I'm going to do is I'm going to work out what px is, because that will necessarily be perpendicular to the displacement vector. And we can work out the value of t, and from that, well, that will give us what OX is and so on, and we should be able to work out P dash. So PX is actually going to be minus OP plus OX, or OX minus OP. We take the second one and minus the first one, essentially. So that is going to equal 13 minus 5t minus 3 plus 3t minus 8 plus 4t, and then we're minusing OP, this one here. So I'm going to be adding 7, minusing 2, and minusing 7, which then becomes 20 minus 5t minus 5 plus 3t and minus 15 plus 4t. That is px. Okay, now px is going to be perpendicular to the, like I said, the direction vector minus 5, 3, 4. And therefore, if we take the dot product between the two, we're going to get 0. The dot product being a dot b equals modulus of a times by the modulus of b times by cos theta. But here, cos theta is 90, so this all disappears, and that's how we get 0. Okay, so this dotted with minus 5, 3, 4 is going to equal, it's a bit of calculations to do, so minus 100 plus 25t minus 15 plus 90 minus 60 plus 16t, that's equal to 0. This means that 50t, when I add all the t's up, then minus 175 is going to equal 0. So t is equal to 175 over 50. I can divide through by 25. That's going to be the best choice. I get 7 over 2. So that means px is going to equal, I can substitute into this one, 20 minus 5 times 7 over 2. So minus 35 over 2. Then minus 5 plus 21 over 2. And minus 15 plus 14. This is 40 over 2, so I'm going to get 5 over 2. This is minus 10 over 2, so I'm going to get 11 over 2. And then minus 15 plus 14 is minus 1. So I'm nearly there. If I now want to work out the position vector of P dash, it's going to be O P dash. Well, I can imagine going O to P and then going 2 lots of PX. That would take me on this journey here to here. I could alternatively do OX plus PX. That would also work. But this one seems a good shout. So I'm going to get minus 7 to 7 plus 2 lots of what I just found. So 5, 11, minus 2, giving me an answer of minus 2, 13, and 5. Nice. On to part B, show that the point A with this position vector, minus 7, 9, 8, lies on L. Well, let's set them equal to one another. Okay, so this implies that t, sorry, I know I'm a bit all over the place in this question. I'm just trying to find space to write t minus 5, 3, 4 will equal, and I can minus this vector from both sides. So I get minus 20 on the left-hand side, then 12, and then, sorry, I think I might have made, oh, that should have been minus 8. I knew that had to be a mistake. 16. And this will be true when t equals 4. So therefore, A lies on L. Nice. Just do that again. On to part C, show that angle PAP dash equals 120 degrees. So we've got a diagram here. I'm going to draw another one. Now, actually, I made a video on this already and then I accidentally didn't save it. So I've got all my working, but I don't have the video. So I'm not going to do all the working again. I'm just going to explain what I did. So I came down here and drew a new diagram with A, P, P dash and X. And then we're trying to work out this angle here. In fact, we're trying to show it's 120 degrees. So we've got the position vectors of A, P, and P dash. We've already worked them out, so I've just written them out again. And what we can do is apply the dot product to A, P dash, and AP. So I worked out both of these. Here's AP dash. I'm highlighting. I do P dash minus A, and then AP is P minus A. So I've got these two vectors. Let's apply the dot product. So to apply the dot product, you times the X components, then you add multiplication of the Y components, and then you add the multiplication of the Z components. So 0 minus 28 plus 3 gives the dot product. But another way of writing down the dot product, as I already talked about earlier, is the magnitudes multiplied together times by cos of the angle in between. So the magnitudes from before were root 50, and then it's cos of theta. So we've got this equation. The left-hand side becomes minus 25, the right-hand side becomes 50 cos theta. Divide through by 50 gives cos theta is minus 25 over 50, which simplifies to minus a half. Okay, now we just need to work that out. We can use the symmetry of the cos curve, like cos of 30 is equal to, cos of 60 is a half. Um, cos of 60 is equal to a half. If we go 30 along and 30 along again, that's going to take us to minus a half. That's what I mean by the symmetry, because it's just gone down and then down again. I mean, ultimately, you can just quote that inverse cos of minus a half is 120. You also get 240 this side over here. We're going to reject the 240 because we're interested in a obtuse angle here, or not, definitely not a reflex angle. So it's fine to just state at this point as 120. I forgot to mention that you also have to find the magnitudes of AP dash and AP, which I'd done down here using 3D Pythagoras. Then I put it into that formula and it's all worked out. Okay, I'm going to return to the main bit of the video that I then continue to make, which moves on to the next part. So it's probably going to jump at this point. All right, it's plenty more still to come. So now we're given a diagram. We've got, remember, O is, say, over here. We've got our the position vector. Oh, sorry, they've swapped it around. So they've got P over here and P dash down here, but that doesn't really matter. Remember, we've got our A that we've worked out from before. And so I'm just trying to remember everything. Oh yeah, we had OP, we've got A. We've just worked out that this angle is 120 degrees. Right, we're now told there's a point PB that lies on L, and then we create a kite, as shown in the figure. And the area of this kite is 50 root 3. Find the position vector of the point B. Right, well, we know a few things. Actually, I've worked out that both of these lengths, sorry, the pen's, okay, both of these lengths are root 50. In the mark scheme, they actually work out P to P dash and work out that length and then do a half times this height times the full length here. But we can avoid having to work that out by focusing just using the half AB sine C formula actually. So area of kite is going to equal, right, the top triangle is going to be a half root 50 times AB times sine of 60, because it's going to be a half this angle here. And then the bottom triangle is going to be exactly the same. So I can just times by 2, cancelling these out. And remember, we're told that this is 50 root 3. Now sine 60 is root 3 over 2. So what does that give me? Root 50 times root 3 over 2 AB is equal to 50 root 3. Therefore, the root 3's cancel. And I can see that this length here, I can times through by 2 and divide through by root 50. When we divide through by root 50, actually this simply becomes root 50, because 50 divided by root 50 is root 50. Okay, so now we've got the magnitude of AB. What I looked at was writing down the vector OB. It's just in S, in terms of S, rather than T. This comes from here. This comes from my original equation. I know that B is on the line, so I've just basically, done a very similar thing to what I did with OX, but I've decided to give it a different name, S instead of T. We then know that OA is this position vector, and I can work out AB by subtracting them. So I now have the vector AB in terms of S. Okay, so if I now work out the magnitude of this, in fact, I'm not going to work out the magnitude, I'm just going to do a squared plus b squared plus c squared equals the magnitude squared. So 20 minus 5s squared is minus 12 plus 3s squared is minus 16 plus 4s squared is going to equal 4 times 50. We can work out what t is. Okay, this is it's a bit involved, but I can't see any really quick way. I will talk about another way of doing it in a minute, but I actually think it's harder. Okay, let's just follow through on it. As long as we can expand our brackets really carefully, we'll be okay. And I'm expecting us to be like a reasonably nice answer. Okay, anyway, let me focus on this. I'm going to get minus 200s. Okay, that's the first bracket done. Second bracket, 16 times 16 is 256. Minus 60 minus 128s. And that is going to equal 200. So I've got 25, 9, and 16. That gives me 50s squared. I've got minus 200s, minus 72s, minus 128. Okay, those two add to minus 200. I get minus 400s. And then 400 plus 144 plus 256 give me plus 800. All right, that's worked out really nicely. I can divide through by 10 straight away. And then I'm going to minus 20 from both sides to make this 60 and this 0. Then divide through by 5 to give s squared minus 8s plus 12 is equal to 0, meaning that s minus 2, s minus 6 is equal to 0. So s is equal to 2 or 6. Okay, this is a little bit of a problem and we need to deal with this. And it's quite subtle actually. If I draw my line back in and put the point x, then I worked out to get from a to x, I had to use t equal to 7 over 2. Remember, we had a position vector getting us onto the line. Actually, let me have it going this way. And that was this one here that I underlined in red. And then we go along some amount of the direction vector. And to get from here to A, sorry, so this should have actually been the whole way. That's 7 over 2. To get from this point here to A, actually, we had t equals 4. That was when we showed that A lied on the line. So actually, we can see as we're going along, t is decreasing. So if it's 4, then 7 over 2, it's going down. It's actually going to be the 2 that we're interested in. Reject s equals 6. T is decreasing as we move right. And that means that OB, we can substitute 2 back into here, and that gives 13 minus 10, minus 3 plus 6, so that's 3 and 3. And then minus 8 plus 8, 0. And that is our position vector of B. One of the way to do this questions is how the Mark scheme did it. They avoided having to do 3D Pythagoras like I did. Their method's like a bit quicker, but I actually think it's a bit it's just less intuitive. I wouldn't have thought, well, I personally wouldn't have thought to do it like this. So in the answers, they actually work out the distance from A to X. And then what they see is actually it's a half root 50. Which is then a quarter of our 2 root 50. It's a quarter of A to B. So they then notice that t has gone down by a half. T is decreased by a half to go from A to X. And so if we're going from A to B, then I'm going to have to times that by 4 and it's going to go down by 2. So if we take 2 away from t equals 4, then we get to t equals 2. It is a nice method, isn't it? You can't deny it. It avoids all the kind of quadratics I've had to deal with, and we don't get this issue of 6, which I got in my quadratic. So I kind of had to go down this path anyway. So it is a good method. I just personally didn't think of it myself, and in my solution, didn't work out what OX was. So there's actually quite a bit to do to calculate AX. Anyway, either way, this is our solution for OB. Right, next up, we're asked to show that angle BPA is 90 degrees. I'm just going to grab another version of the diagram. So when I did this question originally, I know this length, and I think I know this length. Oh no, that was the root 50, wasn't it? Do you know what? Maybe I will go with this method. So this is root 50, and this is 2 root 50. So if we can show that Pythagoras' theorem holds, then we're done. So PB is equal to the position vector B minus the position vector P, which is our newfound 3, 3, 0. And then P from before was minus 7 to 7. I think, where did we find that out? Oh yeah, sorry, we were told that right at the start. That was just so long ago. Which gives us 10, 1, minus 7. So that means the magnitude of PB is 100. So 10 squared plus 1 squared, which is just 1 plus 49 square rooted, which gives the square root of 150. And 2 times root 50 is the square root of 200. So this here is 150 square root of. So then AP, sorry, my pen is just not quite working as I want it to. AP squared plus PB squared is equal to 50 plus 150, which is 200, which is then AB squared. And therefore, angle APB equals 90 degrees. I should probably just say that Pythagoras' theorem holds. The other way to do this question, and the way the answers did it, is to again do the scalar product. Take the scalar product of PB, which we've calculated, with AP and show that it's 0. It's, similar amount of effort for these two. On to the very last part. We're told that the circle C passes through the points A, P, P', and B. Find the position vector of the center of C. Okay, now remember, we've just shown that this is 90 degrees, which means that AB is going to be a diameter. And that is really going to help us in this question because it just means we need to find halfway along AB. So if I try and draw my circle, I don't think this diagram's to scale, so it's actually not going to work out. But that's my circle as best I can do. And here's my origin. So to work out OC, I can get onto the line at A, because remember we've worked that out, or we were given that a long time ago, I think. and then I can add a half of AB. So let's just scout out these things. It's a lot easier doing this on paper. So OA was minus 798. And AB was, oh, we're going to need to now substitute t equals 2 into here because I never actually worked out AB. So I'm going to get, when I substitute, I'm going to get 10 minus 6 minus 8. Okay, so then I'm going to add half of that on. Okay, thanks for sticking with me here because I'm having a bit of a nightmare with my pen, but I'm so far into this question, I'm going to finish it off. So minus 7 plus 5 gives minus 2. 9 plus minus 3 gives me 6. And 8 plus minus 4 gives me 4. That is the position vector of C. All right, I think we can breathe a sigh of relief about that question. That is a pretty epic vectors question. Oh, look how long that was. So do you know what? I don't think I'm even going to give an overview of it. I'm just going to sort of scroll down. We did absolute loads in this question. We had 6 parts to do. Some of them were quite involved. Diagrams, I'd say essential. That trig bit was just seems so long ago now. Just have to work through things really carefully. There's more than one way of doing some parts. I quite like how I did this part, but I did talk about a quicker way. I did Pythagoras here. You could also do the scalar product and then use the circle theorem about 90 degrees and realize that C is halfway between A and B to figure out the position vector. Okay, one final thing to say is well done. Keep going with these challenges, doing amazing.